thread synchronization. Maximum interview questions that you can get in this topic: Java multithreading, Java collection framework, Java 8 and stream API. Thread synchronization. So what is synchronization? First of all, everybody what should clear about the concept. Let we have some threads. Let T1 and T2. Let T3. Suppose we have some threads T1, T2, T3. We have some resources. Let one resources R1. Let this is T1, this is T2, this is T3, this is R1. Let R1 is a resource. Suppose T1 priority is 6. Let it. T1 priority is 6. T2 priority is 9. T3 priority is 7. T1 representing one task, T2 representing one task, T3 representing also one task. Now, T1 started its execution by taking R1. T1 started its execution by taking R1. Now T1 execution is going on. T1 execution is going on. Now, at the time of execution of T1, T2 wanted to access R1 for execution. T1 execution is going on. T2 wanted to access R1 for execution. Then in this context, T2 can access R1 happily because T2 priority is greater than T1 priority. Suppose I am driving my car. I am going on the road. Suddenly in my backside, a boss gave the horn. What I will do? Immediately I will give the side because I will think boss is a heavy vehicle, my car is a light vehicle, boss priority is higher than my vehicle. So whatever I have acquired the resource, road is my resource. So whatever I have acquired the resource, that resource immediately I will release. Then I will give the side, then boss will go, then I will go. That means higher priority thread anytime wants to access the resource, anytime higher priority thread can access for its execution. So that's why I told here T2 can access R1, no problem, because T2 having higher priority than T1. But T1 execution is going on. In the middle portion, T2 wanted to access R1 for its execution. Then T2 is accessing R1. So if T2 will access R1, we can say T1 is not in safe condition. It is not in safe condition, not in or it is not in thread safe. Because any moment a higher priority thread is able to access resource. Now T2 access it. Then what T1 will do? T1 execution already some execution have completed. Then in this case, T1 will go to waiting state. There are some state also. Next time when I will do another webinar, again I will explain. So T1 will go to waiting state. Now T2 completed its execution. Now T2 accessed R1. T2 started its execution and execution completed. T1 have waited. When T2 will complete its execution, then T2 will release R1, then immediately I will access R1. But when T2 completed, T3 accessed R1 because T3 priority is higher than T1. After T2 execution completion, T3 accessed R1. Then again T1 will go to waiting state. So if this type of scenario, this type of situation is happening, that means a thread so is going to waiting state or a thread is waiting. So how many times it will wait? So whatever the operating system will fix the time slot within that time. If T1, T2, T3 will not execute completely, then exception will arise. So here I can say T1 is not in thread set. T1 is not in thread set. Then the developer thought, so how a thread is in safe? So then the concept of locking came to the picture. Lock, L-O-C-K, lock. So what is locking? So when T1 is executing by taking R1, so anyhow, if R1 will be locked by T1, if R1 will lock by T1, then any higher priority thread T2 and T3 want to access R1, they cannot access. They will wait till the release of R1 by T1. So the developer designed that concept. So if we want to see how a thread is in safe condition, so when a thread is executing by taking some resources, anyhow that resources if we will lock, then any other higher priority threads want to access that resource, they cannot access, they will wait. So this is called as thread synchronization. So what is thread synchronization? When a thread is executing by taking resources, preventing any other threads to access that resource is known as thread synchronization. So very important point for interview. So this is known as thread synchronization or locking, lock. So there are three ways to perform thread synchronization. One is there are three approaches to perform thread synchronization, like method synchronization, then block synchronization, and static synchronization. So there are three approaches we can perform thread synchronization. One is method synchronization and one is block synchronization, and One is static synchronization. So first of all, concept, I hope everybody got clear. Then we will go to method synchronization. One method definition I will preceded by the keyword synchronized. There is a keyword synchronized. Then practically how we will know. So it is synchronization, or how a resource will log, or how the resource have not logged, or with synchronization, without synchronization. We will see an example, a program, and we will see without synchronization what we are getting the output, with synchronization what we are getting the output. Let let class demo. Now we will see a program, an example. So method synchronization, but without synchronization, first of all we will see what the output we are getting. Then with synchronization we will see what the output we are getting. Now let class, one class I am defining, because every Java program is nothing but a class. Whatever we will do, we have to do inside a class. A Java program is a class consisting one class or more than one class. So let class demo. One method I am defining. Let public void show method. Suppose I am defining, taking one argument int n. One argument I am defining. One for loop I am continuing. Suppose int I equals to 1, I is less than equals to let 5 I plus plus. I will write system.out.println n into I. So I is equal to 1, then n into 1, I is equal to n into 2, n into 3, n into 4, n into 5. Suppose just I am adding one objective. Suppose for I is equal to 1, for one iteration, so n, so when I will call show method, at the time of call, I will take the value of n. Now one value will display after 500 milliseconds. Another value will display. Suppose 1 I is equal to 1, 1 is less than equals to 5, condition is true, this body will execute. So this, after execution this line, the control will go for sleep. Let it after 1000 millisecond, another output will come. In multi-threading, that concept is available. There is a sleep method. And sleep method, I can write in this way, thread dot sleep within bracket 1000. And for 1000 millisecond, the control will go for sleep. After 1000 millisecond, again second iteration will start. So it is a such method by default. This method throwing checked exception. So that's why we will write within a try block. You remember, checked exception. By default, sleep method throwing exception. Checked exception at the time of compilation. So this exception will arise. So to avoid that exception, we have to write this line within a try block. And once try block we will write, immediately we have to write catch block. that whatever the exception will arise, so it will handle this. Then for loop I will complete, show method I will complete, class I will complete. So again I'm repeating what I did. One class I presented, class name is demo, curly bracket begin, curly bracket end. Whatever anything present inside a class, that is called as class property. Now one method definition I have presented, that method definition show method. Taking one int argument, very simple. So method is not, definition is nothing but a for loop. This is the for loop body. For loop body is one output statement, but one output statement after that the sleep method I have called. One line will execute. After that, control will go for sleep. After 1000 millisecond, again I plus plus I is equal to 2 is less than equals to 5. Again this line will execute. Then control will go for sleep. Then after 1000 millisecond, next value will display. So this is a simple class. Now I will represent two threads. I will represent two threads. Let class my thread 1 extends, currently we new thread class because it is a multi-threading context. Now I will represent two threads. Let my thread 1 and my thread 2, I will represent two threads. So currently we have known how to create a thread, how to represent a thread fully. Class name, extends thread class. Now I will take a demo class object. My thread 1 and demo, we have to create a relationship. So in what I did in my thread class, I took a demo class object or demo reference, whatever you tell. Now I will define a parameterized constructor. Class name, constructor name is same. Constructor is a method. The class name, constructor name is same. Parameterized. Let's same demo D I wrote. So how I will differentiate? This dot D equals to D. One parameterized constructor I define. Class name extends thread class. Here a demo class object I took. Then a parameterized constructor I define. I will explain how it will execute. Then currently we studied without a run method, a thread is not fully defined. It is mandatory. You have to define a run method. I will write public void run method because a run method definition representing a task. So D dot, because demo object D in a demo class show method I have defined. So this method definition will execute when a method will call. When a method will call, then method definition will execute. So now I will call D dot show method within bracket. Suppose I will write suppose 2. So because at the time of definition int n, so at the time of call I took 2. So actual argument, that is a formal argument. Now the value of n is 2. So in this way I presented one thread. Now the thread name is my thread 1. Again I am repeating. Currently what I did, my thread 1 is my thread name, extends thread class, demo object I took, parameterized constructor I executed, and run method definition I presented because run method definition representing our job or our task. Task is what? This is a message passing. So method is invoking by D. D is the demo class object. Then so method definition will execute. I will show you what is the flow control, in which way the control executing. every line. Now this is one thread. Same way, simply I will copy, Control C, another thread I will paste. Simply in place of my thread 1, I will write my thread 2. Here my thread 2. Same things. Here I will write 3 suppose. So in this way, my thread 1 and my thread 2, two threads I defined, I presented. Run method definition d dot show within bracket 2 I passed, d dot show within bracket 3 I passed. Now the value of n is 2 in my thread 1. Now the value of n is 3 in my thread 2. Now I will go to main method class. Let synchronization example 1. Public static word main string args. So now I will first, my objective is I will create a link in between demo class and my thread 1 class. Similarly, demo and my thread 2 class. How? So first of all, I will create a demo class object demo obj equals to new demo. Explicitly, I created an object. So object obj is the object of a demo class. So the object obj representing demo class property. Demo class property this. Now I will create my thread 1 object. My thread 1 is my thread name. My thread 1, let t1 object name equals to new class name my thread 1. Within bracket I will pass obj. Within bracket I will pass obj. Now demo class and my thread 1 class linked because I passed obj representing the properties of demo class. Now obj assigned to t1. Now the object t1 also will represent the demo class property. That means in this way, demo class and my thread 1 class I linked it. So my thread 2, similarly, object name t2 equals to new my thread 2 obj. So in this way, demo class and my thread 2 class I linked because demo class object I specified here. Now the object t2 will represent the demo class property. Now the object t1 will represent also demo class property. So t1 and t2 are two objects. My thread 1 object is t1, my thread 2 object is t2, or we can say t1 is the instance of my thread 1, t2 is the instance of my thread 2. So after thread instance creation, simply I will call start method, t1 dot start method, t2 dot start method. This finish. So what is the mechanism? What is the flow control? When t1 dot start method, when this line will execute, t1 is the object of my thread 1 class. So when start, we know that first you see, first control will come to the main method. The entire execution process I am explaining. First, the control will come to main method. This is the first line to execute demo obj equals to new demo. So obj is the object of demo class. Then control will come to this. So we know that when object is creating constructor, if the class containing constructor, it will execute automatically. So in my thread 1 t1 equals to new my thread 1, at the time of creation of an object, if we are passing some values, so this is the case of parameterized constructor. So when this line will execute, so this person in my thread 1 parameterized constructor will execute obj equals to d. So here obj is the demo class object. This obj equals to d. Constructor executes automatically when an object is creating. Similarly, when this line will execute, my thread to parameterized constructor will execute here obj equals to d. Then control will come to this t1 dot start method. We know that when start method is calling, run method definition will execute. T1 is the object of my thread1 class. Then control will go to my thread1 run method. This part will execute. So what is the body? Body is, it is nothing but a method call. So when this line will execute, then control will go to this person. Now the value of n is 2. So 2 into 1, 2 into 2, after 1000 millisecond, 2 into 3, after 1000 millisecond, 2 into 4, 2 into 5. So this is the mechanism. Similarly, when this line will execute t2 dot start method. We know that when start method is calling, run method definition will execute. T2 is the object of my thread2 class. So control will go to my thread2 run method definition. This part will execute. Now this is the body of run method. Body is nothing but a method call. So when this line will execute, the control will go to this part execution. Now the value of n is 3, n into 1. So 3 into 1 after 1000 millisecond, 3 into 2 after 1000 millisecond, 3 into 3 in this way. You see, so in this the mechanism, but now till now, synchronization representation we have not done. So now, first of all, you see in which way the output is coming, and this is without synchronization. This is without synchronization. So this class name dot Java is my program name. So this class name dot Java, I will do all files and I will save. I will go to command prompt. Then you see Java C. So dot Java. Okay. So this is without synchronization, in which way the output we are getting. Now I compiled. So successfully it compiled. Then I will run. And we will see without sync. This is the case of without synchronization, in which way the output we are getting, and from the output we will observe. You see which way the output is coming. You see. So which way? First the output we will observe. It is very important point. 2 into 1 2, then 3 into 1 3, then 2 into 2 4, then 3 into 2 6, then 3 into 3 9, 2 into 3 6, 3 into 4 12, 2 into 4 8, 3 into 4, 5 15, 2 into 5 10. That means one line from my thread 1, one line of my thread 2, one value from my thread 1, one value from my thread 2, it is coming. That means what we are observing simultaneously, my thread 1, my thread 2 execution is happening, or have executed. So one value from my thread 1, one value from my thread 2, that we have got. But synchronization concept is saying different. Synchronization concept is saying once resource will lock. So for T1 executing by taking R1, and R1 we will log. First T1 will complete its execution, then after complete its execution, then R1 will release. Then means first T1 will output we will get, then T2 will output get. Same way, if either my thread 1 complete output I will get 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5. Then my thread 2 output we will get 3 into 1, 3 into 2, 3 into 3, 3 into 4, 3 into 5. Otherwise, first my thread 2 output we will get, then my thread 1 output will get. One thread execution completely I will get, then after another thread execution completely output I will get. So that is synchronization. Then how I will represent? Very simple. Simply one keyword I will write synchronized. Simply once method, because this method is our main, this method have contained the logic part. So this method definition I preceded by the keyword synchronized. Hence this is representing method synchronization. When a method definition, this is the method definition. When a method definition is preceded by the keyword synchronized, then corresponding object is also one resource among all. Whatever the operating system is allocating resources, that is abstract, that is hidden. We don't know which resources operating system is allocating, but once a method definition is preceded by the keyword synchronized, all the resources are locking. How we will know? You see, now I wrote synchronized. Now I will save, and from the output we will observe. You see, this is without first output, whatever we got, this is without synchronization output. Now, now I will run again. I will compile synchronization example1.java. Now I will run Java space class name synchronization exam. You see, first 2, then 4, 6, then 8, then 10, then 3, then 6, then you see. So from the output we will observe 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, 2 into 4, 8, 2 into 5, 10. So first my thread 1 completed, because in my thread 1 I had written d dot show within by 2. Then 3 into 1, 3, 3 into 2, 6, 3 into 3, 9, 3 into 4, 12, 3 into 5, 15. So when method definition I preceded by the keyword synchronized, then the entire program representing method synchronization. So it is locking. So how we confirmed? From the outputs? One thread executed completely. After completion of one thread, another thread another thread executed completely, and the output we got. So I hope everybody got clarity. This is method synchronization, or we can say this is locking.